Hey everyone, I think we are live. Let me see if okay, let me just open the stream. Cool. Yeah, I think we are live. Let me know if I'm audible. Got 2 out of 3. Good. Yeah. Yeah, I think I'm audible as well. I can hear my voice. Cool. So yeah, let me know how did the contest go overall. Hey everyone, audible. Okay, thank you. So how did the contest go overall? Did you like the problems? Do you not like the problems? Or any other feedback that you have? And also were you able to solve them? Which one did you face difficulty with maybe as well? Yeah. Also, there might be a bit of background noise today. There's a wedding going on like just beside my house. So, yeah, sorry about that. Somehow it is showing me time is left 14 minutes. I think it should have ended. Yeah, cool. Is the last question binary index tree? Yes, it can be solved with binary index tree or segment tree. So today what we'll do is, today we'll not write the codes live. For the first one maybe we'll do because it's pretty simple and straightforward, but for the remaining two I've already solved the questions and I have the working code, right? So we'll just walk through the code and understand like what how I've written it, but we'll not write again, just to save time for you guys as well. Sometimes we run into issues, right, if we write live. So just to save those things, I've just written the codes, working codes, and yeah, we'll just walk through them. Sir, explain in Hindi. Daman, I cannot explain in Hindi because there are many people who are watching this who doesn't understand Hindi, so it will be difficult for them. But yeah, I'll try to, like, if you don't understand some part, right, we'll just I'll try to explain in Hindi, right? We can do that, but it will not be completely in Hindi. Like, I'll first explain in English and then I can explain a few parts in Hindi as well. Okay, we can do that. Speak in English only. Yes, sure. Okay, so let's start with the first problem, right? The problem name is bit magic. The problem statement is, we are given an integer array ARR of size n, which consists of only ones and zeros. Your task is to make the array perfect. What is a perfect array? An array is said to be perfect if for each element I from 0 to n minus 1, ARR I is equals to ARR n minus 1 minus I, right? That is, ARR 0 should be equals to ARR n minus 1. ARR 1 should be equals to ARR n minus 2, and like that. To make the array perfect, you are allowed to do this operation any number of times. In one operation, you can choose two different indices I and j and set the value for both of ARR I and ARR j to ARR I XOR ARR j, right? So you can set both their values to ARR I XOR ARR j. Your task is to make the array perfect in the minimum possible number of operations. Return the number of operations needed, right? So what you are told is, you are given an array with only ones and zeros. The elements, it is a binary array, right? It will contain only ones and zeros. What you have to do is, you have to make it perfect. What is the definition of a perfect array? Definition of a perfect array is, for each index I, it should be ARR I should be equals to ARR n minus 1 minus I. That is the first, that is the reverse, the element in the reverse order in the same index should be equal. That is, it should be palindromic. In other words, it should be palindromic, right? That is the definition here. So you have to convert it, you have to make it palindromic. And what you can do, the operation is, you can take two indices I and j and replace both of them with ARR I XOR ARR j, right? So you have to find the minimum number of operations needed. Okay, so let's take an example. So here it is given 1000. Here what we are doing is, we can choose like 1000. So this one should match with this 0. This 0 should match with this 0, right? That is the question that is given to us. What can we do here is, we can take this one and this 0, right? We can take this one and this 0 maybe, and we can XOR them. Like, we can change both of them. That is, this will become 1 XOR 0, that is 0, and this will become 0 XOR 0, that is 0, right? So it will change. Okay, 101, in this case we do not need any operation, because if you see, this one is equals to this one, and this one doesn't have a like the middle one doesn't have a pair to be matched with, so it is also there. So it is 0, that is, it is already in perfect array, it is already a perfect array, we do not need to make any other operations. So we have to give the minimum number of operations. Constraints are n is 10 to the power 5. Okay, let's understand how do we solve it. So I'll just take okay, wait, do I have a black page? I'm not sure. No, I don't. Cool. Okay, so the idea is very simple, right? Just let's understand what exactly we are telling. We are telling that, hey, we'll map it like this. Let's say we have array like this, 0 0 1 1. So we are telling that this index should be equals to this index, right? Similarly, this index should element in at this index should be equals to element at this index. These two should map. These two should map. Like, it is basically we are creating a palindrome. Example test case are easy to understand. Give a complex. Okay, sure. So actually, like, yeah, let's take a complex example only, right? So let's say 1 0 0 1, and we'll make it even, right? So that everything is paired, and if it is not paired, the middle element is just ignored anyways. So 1 0 0, and let's say here we have 1 0 0. So in this case, what will we do? Just think about it. This one is matching with this 0, should be matched with this 0. This 0 should be matched with this 0, and this 0 should be matched with this 1. So this is how we should match. What is the number of operations? Okay, we'll find the number of operations needed, right? For that, let's actually understand this. So when something is not matching, what does it mean? At one end, it should be 1. At the other end, it should be 0. Then only it is not matching, because these are the only two possible values, right? 1 and 0. If at both the ends, it is 0 or it is both 1s, then they are matching. Only when at one end it is 1, at the other end it is 0, the corresponding end, right? Like if it is index I, this should be index n minus 1 minus I. So at one end it should be 0, at one end it should be 1. Okay, in that case, they are different. Okay, now let's consider a couple of cases. First case is that all the mismatch in the, so let's consider only one half, right? Anyways, like we will just we have to just make the first half. This is the first half, like 1 0 0 1. This equals to 1 0 0. Rather, this one is ignored. 1 0 0, this is the first half, and in between there is 1 which is just ignored. We have to make this equals to 1 0 0, right? Rather, in the reverse order, like this 0 should map to this 1, this 0 should map to this 0, this 0 should map to this 1, in the reverse order, right? So we have to just compare between two. So let's just take one of the halves, because if we know this half, right, if we know this half, that there is a 1 here, we know that there is a mismatch. We know that for this 1 there is a mismatch in the corresponding index. So we know that this index should be 0, because there is a mismatch, so this one should be 0, right? We already know that has to happen because there is a mismatch, and we are matching this one with this one, so this one should be 0 if this one is 1. Okay, now let's assume, let's take the first half and let's have all the mismatches, right? Let's have all the mismatches. Let's take the case when all of them are ones. On the left half, whatever mismatches are there, all of them are ones, right? All the mismatches are 1. Their corresponding on the right hand side will be all zeros, right? Their corresponding on the right hand side will be all zeros. What we can do is, we can just group them 2 at a time. We can just group them 2 at a time and XOR them. So this will become 1 XOR 1 0, 1 XOR 1 0. Again, we'll group them 2 at a time, 0 and 0. Let's just consider the case of even as of now. After that, we'll tackle odd. When the number of mismatches is even, right? Number of mismatches is even, that's what we are tackling. So let's understand again. So number of mismatches is even, right? Only for this case right now we are computing. So first thing is, in the first n by 2, and we are just considering the first half of the array, first half of array, that is 0 to n by 2. Only this range we are considering, right? So we are saying that all the mismatches that are occurring in the first half of the array, definitely the mismatch has to happen with the second half. Like I has to have a mismatch with n minus 1 minus I. And this n minus, if I is in the first half, n minus 1 minus I should be in the second half, right? So we are just restricting that in the first half only, because if we know the elements in the first half, if we know the mismatch, what are the mismatches and what are their corresponding elements, we can easily tell what is the element in the second half, because it is a mismatch. So if there is a 1 here, this will be a 0, or if there is a 0 here, this will be a 1. So we do not need to consider both of them. अरे भाई एक्सप्लेन करने दो पहले, फिर लिखते हैं आराम से. ओके, सो n minus 1 minus I, right? So okay, this part is done. So now let's understand with the case when all the mismatches, right? First case is all the mismatches in first half are ones. Like whatever mismatches are happening in the first half, they are all ones. Let's first consider even number of mismatches. So when there are even number, let's say 4 mismatches, we saw their corresponding right hand side will be 0 0 0 0. We have to convert each of these ones to zeros, so we can pair them up and create zeros. Like we pair this I and j, and both of them will be replaced by I XOR, like a of I XOR xj. This was the operation. A of I XOR a of j, both I and a of I and a of j will be replaced by this. So 1 XOR 1 is what? 0. So both of them become 0. 1 XOR 1 is 1, 0. Right. So when there are 4 mismatches, we see that we can pair them up and have it solved within 2 moves. We can have it solved within 2 moves when there are 4 mismatches. Let's consider the case when it is odd. Odd number of ones are there, right? So 1 1 1 1 1. In this case also, we can just pair these up, right? And for this one, what we can do is we can just pair up with its corresponding n minus 1 minus I. Let's say this is at index 4 and n is total, there are 10 elements. 10, yes, sorry, 1 2 3. This is index 3. Let's say this is index 3 4 5 and 10 elements are total there. So this will be what? This is 10 minus 6 minus 1, right? So that is, sorry, 10 minus 3 minus 1, 7 minus 1, 6. So this should be 6. At 6 there is a 0. So we'll pair up with this, right? We'll pair up with this and replace the values. So 1 XOR 0, this will replace to, these all replace to 0, right? This will replace to 0. XOR of 1 XOR 1 is 0. 1 XOR 1 is equals to 0, right? This also will replace to 0. This will pair up with this and it will replace to what? 1 XOR 0. So that is 1, and this will replace to 1 XOR 0, that is 1, because 1 XOR 0 equals to 1. So we see that for odd, there were how many mismatches? 1 2 3 4 5. For 5 mismatches, the answer becomes 3. For 5 mismatches, the answer becomes 3. For 6 mismatches, the answer will remain 3, right? Because we can pair 2 of, like we have 6 ones, we'll pair them. How we know each element is mismatch? The question tells that, right? The question tells that if a of I not equals to a of n minus 1 minus I, for I equals to 0 to n by 2, if this is satisfied, that is a mismatch, and we'll store them, right? We'll just store them, and we are then doing this, right? Only for the first step, we are finding what are the positions of mismatch. And when I'm talking about mismatch, it is happening with the second half, right? A of I not equals to a of n minus 1 minus I, because it has to be equal to become a perfect array, right? So this was the condition. Okay. Now we saw that, again, what is the formula? The formula turns out to be number of mismatches. Let's call that x. Number of mismatch is x. So x plus 1 by 2, right? Why? Because again, 4 is, we are always pairing up, right? 4 is getting paired up to 2. For odd numbers, we are just going up to the next integer, because one additional pair will be formed with the number that is left and its corresponding mismatch, right? This pair additionally will be formed. But you're considering on the left one, how we know second part was, bro, what is the question? What is the question? The question, what is the definition of mismatch? ARR I equals to ARR n minus 1 minus I. It has to be true, right? So what I'm saying here is that, okay, let's understand with an example. 1 0 1, this is the first half. Let's say the second half is 0 0 0, right? If I am saying that this index and this index are mismatched, how am I saying that? Because this index should have been matched with this index, right? And we see here is a 1, here is a 0. This index should have been matched with this index, and this is matching. 0 is matching with 0. This index is should have matched with this index, but here is a 1, here is a 0. So definitely there is a mismatch, right? If the first half, if we are just considering this part, that we are just saying that this is a mismatch, this is a mismatch. We are not taking these indices into consideration yet. The reason being, we do not need to. We just have to know that if here is a 1, if we know this is a mismatch and there is a 1 here, the corresponding entry has to be 0 on the right hand side. If it was 1, it would not have been a mismatch, right? If it was 1, would it be a mismatch? This one and this one, is this a mismatch? A of I should not be equals to A of n minus 1 minus I. Then only it is a mismatch. If this is 1, this is 1, it is not a mismatch then. Then we'll not consider it as a mismatch, right? अभिषेक तुम पलवेल निकल जाओ भाई, तुमको रहना नहीं है इधर, निकल जाओ. I don't care if you want to leave, just leave. Okay, so so this has to be 0 because here is the 1 and we are saying that this is a mismatch. This has to be 0. Similarly, this is a 1, this is a 0. This has to be 0 because we are saying that this is a mismatch. This has to be 0. Similarly, this is a 0. We are saying that this is a match. This is not a mismatch. So this corresponding index has to be 0. So we are just taking the first half. We just have to compare with the first half. If we just take the first half, the second half becomes clear for us, right? Because there is a mismatch. So we are sure that the corresponding entry has to be the reverse of it. If it is a 1, the corresponding entry in the second half has to be 0, right? Okay. Now, okay. Does it make sense, Abhishek? Arey Abhishek, I'm not talking to you. I'm talking about Abhishek Raj coding. Abhishek Podwal, I'm not talking to you. I was explaining you. Does it make sense, Abhishek? Yeah. I'm talking about that. This part is clear, right? We are pairing up. We are just taking the first half, right? We are just taking the first half. Is this clear? Because if we just tell that this is a mismatch, and when we compare mismatch, we'll definitely compare with the second half. Only then we'll know that this is a mismatch, right? But we are taking the first half, this 1 and this 0. We are considering this as a mismatch only because this is not matching to this one. So if we know that this is a 1, we know the corresponding element in the second half is 0, right? This part makes sense. Okay, so what we'll do is now let's talk about, so why are we pairing up with the first half? The question, that is because if you think about it, let's say there are 4 mismatches in the first half and all of them are 1, right? All of them are 1. So what we are saying is we can just pair them up like this. What is the operations that we can do? Like if you look into the operation again, the operation is we can take ARR I and ARR J and we can replace both of them to ARR I XOR ARR J, right? So we are saying that in the first half, in the first half, we have 4 mismatches, that is mismatches with the second half, right? And all of them are 1. So the corresponding indices elements in the second half has to be 0. They has to be 0, right? They has to be 0. So we have to make this into 0, 0, 0, 0 so that it becomes a perfect array. How do we do that? We take them pairs and we'll just XOR them, right? So this as I, this as J, and we'll make a operation. So when we make the operation, what happens? Both of them get replaced with ARR I XOR ARR J, that is 0, 0. Here also 0, 0, right? Similarly, we also saw, this is case of even. We also saw when there are odd number of ones, we can just pair these two up. This is again in the first half. For this one, which is left alone, we can pair it with the corresponding n minus, let's say I is left alone or k is left alone. We can just pair it with n minus 1 minus k. Its corresponding entry in the second half with which it is matching, and we can just XOR them. And we'll just have one more operation added to us. So we saw that it is always count plus 1 by 2 for all ones. For all ones, like when the mismatches in the first half are all ones. So for all ones, it is count plus 1 by 2. We can in fact prove that for any mixture of ones and zeros, right? There are x ones and y zeros. It will always remain count plus 1 by 2. We can always pair them up, right? And one additional pair will be formed only for odd elements. How do we know that? Okay, let's see that. So one additional pair. So now we are saying that, okay, let's say there are two ones and 1 0 mismatch, right? In the first half, there are 2 ones and 1 zeros. That is, there is, let's say, a 1 here in the corresponding element in the second half, that is 0. Again, there is some 1 here. There are some elements in between, and there is a 0 here. And here somewhere there is a 0, and somewhere there is a 1 in the corresponding second half, right? And there are some elements in between. So again, these are mapping, right? These are the matching element, like what should match. So they are mismatches. Okay, let's take the case of even actually better. I think that makes more sense, right? With even. So let's say there is another 0, 2 ones and 2 zeros. So there is another 0 somewhere and there is another 1 somewhere, right? So there are 2 ones and 2 zeros that are mismatching. Again, we can pair them up, right? Because why we can pair them up? Because we have a 1 here. These 2 ones can be paired up together. And these 2 ones can be paired up together. So the second half can be paired up together. So again, the answer becomes the same thing, right? Let's say when it is odd, so let's say 2 ones and 1 0. 2 ones and 1 zeros. In that case, can be paired up. Let's see. So 1 1 and there is a 0. This is mismatch, and corresponding 0 should be 1 and this corresponding 1 should be 0. Again, we can pair up, right? These two can be paired up together. This can be paired up with this one, and this will become 1 and this will become 0. Its corresponding element in the second half. So it always becomes what? We can always pair up, right? It's always turning out, even in case of mixture of ones and zeros, like if we have in the first half a couple of ones and couple of zeros, we can always end up creating pairs, right? That's the understanding that we need here. So let's say there are x number of mismatches. The total number of mismatches in the first half, only in the first half we are concerned about, the total number of mismatches is x. So we can pair them up and basically solve the question. So the total number of pairs that we need, or total number of operations, will be x plus 1 by 2. Why x plus 1 by 2? Because when it is odd, we would need one more operation, right? We would need one more operation. For even, if you see x plus 1 by 2, when even, let's say 2 plus 1 by 2, that is 3 by 2, it anyways becomes 1, right? Which is equivalent to 2 by 2. So for even it is not affected. For odd, let's say there are 3, so 3 plus 1 by 2, that is 4 by 2, that is 2 operations. So one operation, so 1 plus 1 operation, because of the single element that was left out, it can be paired up with its corresponding n minus 1 minus I, and it can be then the operation can be performed. So that will be the final formula that is needed. So yeah, that's the code. Nothing else is needed. Again, I think you can write it yourself, but anyways, let's write it. So pretty simple code, like we'll just go through int answer equals to 0, for int I equals to 0, I less than equal to n by 2, or 2 into I less than equal to less than n, I plus plus. If ARR I is not equals to ARR n minus 1 minus I, in that case answer plus plus, and return answer plus 1 by 2. Okay. One question, can we say that number of mismatches equals to number of ones that we can pair up? Not necessarily. The mismatches can be equal to zeros. Actually, yes. because if it is a 0 on the other end, it is 1. So number of mismatches will essentially be number of not all ones, but the ones that are mismatching, number of ones that are mismatching, right? Because it might happen, let's consider another example here. It might happen that 1 1 1 and on the other end 1 0 1. So in this case there is only one mismatch, right? So yes, the mismatches are always will have 1 1 and 1 0, but in one of the halves there will be definitely a 1, but it is not all the ones, right? It is not all the ones. So yeah, like we can just pair them up and that should solve, right? So yeah, let's submit. Why not? Same thing, right? N by 2, again 2 into I less than n is also equals to n by 2. I avoid doing division because again for this it will not cause any problem, but there might be unnecessary side effects. So again that's something I prefer, like for example I into I, like square root of n, I into I less than n we write, right, instead of I less than n by I. So again it's, there might be rounding up and these things, but again here it should not be a problem, but it's always better to avoid division as much as you can. And multiplication, yeah, it's always better. But again this condition is same thing, right? 2 into I less than n is same as I less than n by 2. Okay, let's go to the second question. The second question is minimum time. Okay, so the question is, Geek, being the brightest student of the class, is given the tasks to solve n puzzles by his teacher in the minimum possible time. The puzzles are numbered 1 to n and he has to solve them in order of their numbers. So he has to solve the puzzles in the order 1 to n only. Geek can solve a puzzle in two ways, either solve on his own or he can copy from the book. As Geek is busy these days, so he has asked for your help to compute the minimum time needed to solve all the puzzles, right? For you to do the task, he has provided with an array integers time and of size n, where time of I is what is the time Geek would need to take, Geek would have taken to solve the ith puzzle on his own. Also, he has given you an integer array search of size n, where search of I is what is the time taken if you would search for the puzzle I, right? Search for the puzzle I. But there is a take here that if he searches for the puzzle I, then he will also know the answer for the next k puzzles, right? He will also know the answer for the next k puzzles. So that is, if we take, like, let's say he searches for the 2th, again he can do two operations. First is he can solve the puzzle himself or he can copy it from somewhere else, right? So when he solves the like less than k puzzles, so what he can do is, when he solves the ith puzzle, he has two choices: either he will solve it himself or he can search for it. But when he searches for the ith puzzle, he also knows the answer for the next k puzzles, right? So up to I plus k, or if it like I plus k is greater than n, so up to n, like the last elements, right? So he knows the answer for them. So what you have to tell is, he can directly jump to any puzzle I plus j, where j is up to min k comma n minus I, right? So basically he can jump by k steps. Basically, let's say he's at index 2 and k is 5 or k is 3, right? So if he searches for the puzzle at index 2, he will know the answer for 2 3 4 5, like next three elements, 2 3 4 5, right? He will also know the answer for 3 4 5 as well. He can decide whether for 3 4 5 whether he wants to jump 3 4 5 and directly go to 6, or he wants to solve one of 3 4 5. Yes, he can search, right? So he can jump directly to that part, index I to I plus j minus 1. It is not okay, it is I plus j minus 1, right? I plus j minus 1 by copying I plus j, and j is minimum k to n minus 1. So it is not necessary for Geek to copy all k puzzles after I when he searched for the book at ith puzzle. So you have to determine the minimum time Geek will take to solve all the puzzles, right? Okay, so here 3187 and 4462. So what he can do here is, and k is 2, so he can solve the first puzzle himself. So it will take 3 time equals to 3, right? for the second puzzle, he can search the book. When he searches the book here, it takes him a time of 4 units. So total units is 7, but he knows the answer for the next 2 puzzles as well, right? 7, and he knows the answer for the next 2 puzzles, that is 1 and 8. Sorry, not 1 and 8, puzzle 1 and 2. He knows these 2 answers, right? 4 and 6, these 2 answers he knows. After that, he can directly jump to 7 and get this answer plus 2, like just search for this again, and he will get plus 2 again, so 9 total, right? Yes, right. So that's the minimum time he would need. Okay, let's understand how do we solve this. And those who have already solved this, right, those who have already solved this, a challenge for you. The solution you are telling, or anyone who has solved this, would be n squared, right? So you have to bring it down to order of n. How would you bring it down to order of n? That's a challenge for you. The screen is getting blurred. Is the screen getting blurred? Okay, so anyways, like what I was talking about is the example here. Example is the first one. He has 2 choices. Either he can he can do the puzzle himself, or he can search for it. So let's say he decides to do the puzzle himself. So he takes 3 units of time. For the second, he can again search for, do it himself or search for it. He decides to do it like search for it. So it will take him 4 units of time, but he would know the answer for the next 2 puzzles. So next 2 puzzles he doesn't need to take care of. So this one and this one. So next he goes to this and again searches for it. So the total time becomes 4 plus 3, that is 7 plus 2, 9. Right. So in 9 units of time, he can complete all the puzzles. Okay. So yeah, those who have solved it, how can you reduce it from order of n squared to order of n? That's your challenge, right? And those who haven't solved it, let's understand now. So now at any index I, right, at any puzzle I, what choices does what is the name of the person? Geek. Okay, what choices does Geek has? At any point of time, what choices does Geek have? He has 2 choices, right? One is he can do it himself. In that case, we will use the times array. He will take the amount of time equals to times of I. Or he can copy it or search for it. Copy or search for it. In that case, he would need the time equals to search of I. Yes, search and solve or copy. Yes, exactly. So if he decides to search for it, the next position where will, so if he does it himself, the next element he will solve for is I plus 1, right? He will solve the I plus 1 puzzle next. The next puzzle he will solve is I plus 1. But if he decides to search and copy for it, the next puzzle he will solve can be 1 of I plus 1, I plus 2, I plus k minus 1. Like, sorry, I plus k. The next puzzle he will solve can be any of these, right? The next puzzle he can solve can be any of these. I plus 1, I plus 2 up to I plus k, right? He can decide, like, whichever he solves next means the previous ones. Let's say he decides to solve I plus k next. So that means up to I plus k minus 1, he is not solving because he has searched for it. He knows the answer for it. Next, he will directly solve I plus k, right? Okay. So that's the idea. So again, when we have 2 choices here, we are definitely going towards the DP solution, right? So let's say, what is f of I? F of I is what? F of I is the minimum time needed to solve the puzzles from I to n or n minus 1, whatever you want. The minimum time needed to solve the puzzles from I to n minus 1, right? That is I plus 1, I plus 2 up to n minus 1. The minimum time needed to solve the puzzles, that is given by f of I. So at f of I, at the ith index, at the ith puzzle, what he can do? He can either do it himself, So what he will end up with? He will end up with I plus 1 puzzles. He will end up at puzzle I plus 1. F of I plus 1 is what? The minimum time needed to solve the puzzles from I plus 1 to n minus 1. The total, so the time needed here is what? The minimum time needed from I plus 1. That from I, geek goes to I plus 1, and from I plus 1 he takes the minimum time to solve the up to n minus 1, right? Let's say this is given by x. So the time taken at I, the minimum time taken at I is what? X plus the time taken for ith step. Ith step is what? He's doing it himself. So I plus 1 plus times of I. But he can search even if he has and copy next j plus instead eliminate any bottleneck. Am I correct in my understanding? He can search even if he has answer for j and copy next j plus a. Yes, exactly. So he has a choice. Let's say he takes, he searches for it. He has a choice. What is the next he wants to like decide on? Like from I plus 1 to I plus k, one of them he has to solve next. In worst case, in best case, he can solve I plus k next directly, right? But he can decide to solve something in between or directly I plus 1 as well. Even after searching, he can directly decide to solve from I plus 1 itself, right? It is his choice what he wants to do. It is not necessary to make a jump of k. You can think about it as like jumping, right? You can think about it like jumping. He has a choice. Either he wants to jump by 1 step or jump by 2 steps or jump by 3 steps or jump by k steps, right? So if he jumps by k steps, the next element he will take care of is I plus k. So that's there, right? Okay. Make sense? Okay. So for the first thing, okay, let's think about jumping only, right? Instead of solving, let's think about jumping. So he jumps. When he takes this move, he just jumps to I plus 1. And from I plus 1, what is the minimum number of steps? That is given by f of I plus 1. So this is one of the moves. The second move is what? He can search for it. So this is basically solves. And this is searches. He searches for it. When he searches for it, he can go to any I plus x, and from there, like from I, okay, let's do it here itself. From I, let's say he has searched for it, so he knows the next k answers. Let's say he decides to go up to some I plus x, and from there he decides to decide on like how to go to n minus 1, right? So what is the minimum number of steps needed from I plus x to reach n minus 1? It is f of I plus x. He decides to jump to I plus x directly, and plus as he has searched for it, so the total time needed for searching is search of I. And what does he want? He wants the minimum over all x. What is x? X is 1 to k. So either he can decide to go to jump to I plus 1, or he can decide to jump to I plus 2, or he can decide to jump to I plus k directly, right? Just think about it as jumping. He can decide to jump to I plus 1, I plus 2, I plus 3, like that up to I plus k. So whatever it gives the minimum result, he will jump up to that part, and next it will be solved by f of I plus x, and x is 1 to k. He can only jump maximum up to k, right? Maximum up to k. So these are the two moves that he has. The answer will be the minimum of them. The answer will be the minimum of them. So that is the entire solution, right? So base case will be f of n equals to 0, and for any general I, f of I will be equals to what? F of I will be the minimum of f of I plus 1 plus times of either he reads it or he searches for it. So the minimum over again, j equals to 1 to k, f of I plus j plus search of I. So this is the answer, right? This is the recursion. Does it make sense? This is the recursion. For example, let's say at index 2, let's say k equals to 3, right? At index 2, geek decides to search for it. So next from 2, he can either like he has done 2 already. He can either go to 3 and from 3 he can decide the best path, or he can go to 4 and decide the best path, or he can go to 5 and decide the best path from there, or he can go to 6 and decide the best path from it. So he can read up to 5. He knows the answer up to 5, but he can decide whether to go to 3, 4, 5 or 6 and then take the best path from it, right? So that is given by this expression. I hope this makes sense. So yeah, and that's the logic. So this is what is the complexity here. The complexity will be, for state it is in, for every state we are running a loop of length k, right? From 2 he can go into in 2 ways by himself. No, that is there, but I am just talking about when he searches at 2. Sorry, when he searches at 2 he has these choices, right? When he searches at 2 he can decide next he wants to go to 3 and then take it from 3, or next he wants to go to 4, because he knows the answer for the next k moves. But again, it is up to him to decide whether he wants to solve it from there or already use the answer that he knows. It is up to him, right? So just think about this part, like searching. Just think about searching as he can jump up to k steps. Like either he can jump from I to I plus 1, or he can jump from I to I plus 2, or he can jump from I to I plus 3 up to k, right? He can jump from I to I plus k. Just think about it like jumping, right? So that's why we have this expression minimum of I plus j. Okay, what is the complexity for each of the states? For the state it is then, for each of the states it is running a loop of length k, right? It is running a loop of length k, so it is n into k. The complexity is n into k. How do you reduce it? How do you reduce it to n? Anyone? How do you reduce it to order of n? All the n into k will work for us. N into k, but how will you reduce it to order of n? Anyone has any idea? One question, at 2 he can't jump to 6, right? 2 plus 3, 5, right? What do I mean by jumping? By jumping I'm not meaning skipping. By jumping I mean what is the next book he's solving. So at 2 he can jump to up to, like he can skip up to 5. That is the next element he will read is 6. So jumping means what is the next element he will read, not or what is the next element he will decide, he has to decide for. He can skip up to 5, that is the next element he can read, has to decide for is 6. Aman Singh is saying DP we are already doing, right? With DP we are getting n into k. How do you reduce it to order of n? Anyone has any ideas? K includes I, right? So what I'm saying is, dekho, let's say if I do f of I plus 1, what does it mean? It means that he has read ith book and for I plus 1th book he is deciding. Similarly, when I write f of I plus k, what does this mean? He knows the answer from I plus 1 up to I plus k minus 1. He knows these answers, and at I plus k he is deciding whether to read or do himself solve, whether to read or solve. Nikhil, it is sliding queue. Yes, exactly, very good. So what do we want here? Think about it again. We want the minimum from, what was the expression? I equals to 1 to k, minimum of f of I plus, sorry, j equals to 1 to k, minimum of f of I plus j. That is minimum of f of I plus 1, f of I plus 2, up to f of I plus k. Right, the minimum of these values. Let's say we treat it as index. Let's say we treat it as array. So it's similar to this, right? Minimum of a of I plus 1, a of I plus 2, a of I plus k. And how do we solve it for every subarray? Right? For every subarray. For every subarray of length k, we are computing the minimum of the window, or for every window, sorry. Rather, for every subarray, we'll call it for every window. For every window, these two are equivalent, I'm saying. So we are computing the minimum for every window, right? How do you compute the minimum for a window? For a running window, for a sliding window, for all windows. How do you compute the minimum? Using a DQ, sliding window minimum. It's a very popular lead code question, very popular interview question. Given a array and a window size of k or a subarray size of k, find the minimum element for each subarray of size k. We use sliding window for that, for order of n. And same thing we'll do here. We'll use a sliding window approach to reduce the complexity from order of n into k to order of n. Right? We'll just use sliding window to reduce it from n into k to order of n. Because that's exactly what we need, right? We want the minimum from I plus 1 to I plus k. And we know that for whenever we want minimum. So you can think about it, f of I plus 1 k jagah, you can think about it as like dp. In an array, dp of I plus 1, dp of I plus 2, up to dp of I plus k. You want the minimum out of them. So in the sliding window, you basically, that brings up a sliding window approach, right? So we can maintain a sliding window for this and can compute the minimum. Okay, let's look into the code if it makes any confusion, but that's the idea. Let's look into the code, right? Okay, so first of all, dp of n, we are creating dp of n plus 1 size. dp of n, we are initializing with 0. dp of n minus 1 will be what? At n minus 1, we can just decide whether to read it or search it, because anyways we'll end up at n, right? So we can just decide whether to read it or search it. So it will just be the minimum of times of n minus 1 or search of n minus 1. Then we take the dq, because dq will be for what? The sliding window. For sliding window, we need the dq, right? So we'll have the dq, and in dq we'll push the two indices that we have computed, that is n and n minus 1. So in the dq, we'll not maintain the array values, but rather the indices. It makes more sense to maintain the indices because that gives us more flexibility, right? So again, I'm not talking about how we are doing this, how we are doing a sliding window minimum. How does sliding window minimum work? That is something that you should already know. If you don't know, there's a lead code question. It's a very popular one. There are so many videos out of for it. Just learn about how to compute sliding window minimum, right? There is GeeksforGeeks article as well. So for int I equals to n minus 2, we'll run the reverse loop now. I greater than 0, I minus minus. First condition is I less than n minus k. That is because if it is greater than n minus k, basically we do not have to remove from the window, right? We haven't got k elements of the window yet. We'll only start removing from the window when we have k elements in the window. So that time we slide. So that time we have to remove elements from the window. Like basically what I'm talking about here is, let's say your window size is 3, right? So let's say n is equals to 5. So 0, 1, 2, 3, 4. So if these 3 elements are there, like these 3 is a window. So when we are computing, like let's say 3 or 2, we do not have to remove from the window. Only when we slide the window from here to here. Only when we slide the window from here to here, only then we have to remove this 4. So that is basically maintained by this, right? That is maintained by this if condition, that will only remove when I is less than n minus k. Only then we'll start removing. Yes, we'll have minimum. We'll maintain the minimum at the front always. We want the minimum, so we'll maintain the minimum at the front always. So in that case, if we have to remove, we'll check if the front element equals to the element that has to be removed. That is I plus k plus 1. Because I plus 1 to I plus k should be there in the queue. We want the minimum of that part, right? I plus 1 to I plus k. So that should be in the queue. So the next element that has to be removed is I plus k plus 1. If that is equal, in that case, we do dq.pop front. We'll remove it from the front of the queue. Otherwise, dp of I, first one choice is for us, is dp of I equals to dp. We can either just solve it ourselves. So dp of I equals to dp of I plus 1 plus times of I. Or we can choose to search for it. So in that case, dp of I is minimum of dp of I, or dp of dq.front. dq.front will return the index, right? Whichever is the minimum in the range of I plus 1 to I plus k. whatever is the minimum value of dp from I plus 1 to I plus k, it will return its index dq, because dq is storing the indices. So dp of dq dot front will get the minimum dp value plus search of I, right? And next we'll have to insert this. So we are sliding the window, will be we are moving, we have to insert this current for the previous element. So when we slide the window, because we'll slide the window to the left, so when we insert, we'll just check. This is basically the sliding window, right? Remove the elements as long as the elements are greater, like from the back, we'll remove elements from the back as long as the elements are greater than equal to dp of I, because they can never be the answer, right? They can never be the answer. Dp of I will always be the answer for those parts. And finally we push I into the queue. So this part is the sliding window. This is the standard sliding window minimum approach that we have done, but this is how we can optimize, right? This part, see, now it has become order of 1. We are just using the dq to tell us what is the minimum instead of looping over I plus 1 to I plus k. Instead of running a loop of length k, we are just using the dq to tell us the minimum. So is this code clear with everyone? Is this clear with everyone? Any doubts? Anyone has any doubts with the code? Again, not explaining. I'll not explain how sliding window works. If you have doubt there, you have to solve it yourself. You have to figure it out yourself. But once you know, after that, after you know sliding window, after that, do you have any doubt? Bro, for the first question, can you please explain for the test case? I'll take up first question later. Like if we have time after like done with the third question, we can take up that, right? Or actually, let's do it. It will be a simple input. Let's quickly do it, right? So your example, your 1-1. Meanwhile, others try to understand what I've said about this problem. Let me know if you have any doubts, and I'll explain him, right? So what we're telling is we'll divide this array into this part, right? The middle element, again, we do not have to consider because this is anyways matching, right? For this, so for only for the left part, we'll figure out what are the unmatching elements. So first of all, we'll start with this element. Is this matching with 1? Yes, it is matching. So this is not unmatching, not mismatching. So this 1 is matched with this 0. This is a mismatch. So we'll know that this is a mismatch. So there is a 1 here. Next, we'll come to this 0. For this 0, there is a 1 here. There is a 1 here, right? 1 here, 0. So this is also a mismatch. So we have 1, 0, 1, 1. Now, what we can do is, when we know that there is a 0 here. So the corresponding element on the right part will be 1. So we can just pair this 1, because here what do we need? Here we have a 1. Here we have a 1. We need a 0. And again, you can think about it here as well. Here we have a 1. We need a 0. So we can just pair them up. We can just pair these two, right? Let's mark it in red. We can just pair this element with this element and XOR them up, right? XOR. So 1 XOR 1 is equals to what? 0. So what will be the final array? After the operation 1, this will get updated to 0. Next element remains 0. After that, it remains 1. Next element we had paired up with it, so it becomes 0. Next element remains 0 and 1. Now it is a perfect array, right? Now it is a perfect array. Can you write the recursive code? I'll not write the recursive code. You try to write the recursive code yourself. Recursive code is pretty simple to write. This is the iterative. I'll not write the recursive code. Write it yourself. Try to write it yourself. But again, when you are doing optimizations like this, iterative code becomes much simpler to write. But you can write a recursive code as well, because all these will be already computed. So in the queue, you would necessarily have that in only. So just same thing, you'll just do the same thing, right? Instead of dp of I, here you would do like f of I equals to f of I plus 1 plus times of I, where f is the function. Okay, try to write it yourself. Maybe a good solution, but yeah, like this is the idea, right? This is the idea for the entire thing. Okay, let's go to the last question. Okay, last question is very simple actually. I'm not sure why there is a 7.83% accuracy. It's very simple, right? Okay, let's see. So the problem name is easy task. The problem statement is, given a string s whose length is n and array queries of length q where each element of queries is either of type 1 or type 2. So there are two types of queries given to us and we are given a string of length n. What are the queries? Type 1 queries is you are given type 1, the first element is type 1, that tells the type of the query, ind, some index and some character. What it tells is that in this query you have to change the character at index ind with the character given by this one, right, cat, right? So that is what you have to do. For query of type 2, what you have to do is you are given 2 left, right and k. You are given 4 values, 2 left, right, k. 2 basically means the query is of type 2, nothing else. Query is of type 2. What it tells is that you have to return the kth lexicographically largest character. Kth lexicographically largest character, not the smallest character, largest character, kth largest character in the substring of s from left to right. In the substring of s left to right, you have to return the kth lexicographically largest character. What is the lexicographically largest character? It means if the characters are sorted, if all the characters are taken in this range from left to right and they are sorted, what will be the kth character from the end? What will be the kth character from the end, right? So also it is given that you do not have to give the distinct character. You do not have to consider distinct character. Like let's say there are multiple a's, you have to consider all the k's, all the a's as well. You have to tell if all the a's are there, all the b's, all the c's, whatever is there, you have to tell what is the kth character in the sorted, final sorted list of characters in this range, right? So that's what you have to report. You have to perform each query in the same order it is given, and then you have to return the answer for each of the type 2 queries, right? For type 2 you will have answer, for type 1 it is just an update operation. So let's understand this with an example. First of all, we have AB as the string. Now we have a query that at index 2 make the character D. So index 2 is what? 0, 1, B is at 1, then A is at index 2. At this index make it D. So it will become ABDB after the query. Now you are given the range 1 to 3 to 1 to 3. In the range 1 to 3, that is 0 from 1 to 3, that is in this range, BAB, or rather in the updated array BDB, what is the kth, that is the first largest lexicographically largest character. What is the first largest character from in BDB? D is the largest character. We have B and D. D is the largest character. First largest character will be D. So the answer will be D. The answer will be D, right? Is the question clear with everyone? Is the question clear with everyone? Anyone has any doubts with the question? Anyone has any doubts with the question? Okay, let's take this example. Yes, sure. Let's take the second example as well. We have AAA, right? Okay, let's write it down as well. AAA. We'll write it down as well. So we have AAA. What are the queries? The queries are 11E, 11E. After that 12C, 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 and finally 2122, 2122. Okay, 2122. What does it tell? It tells that, so this is the index, right? 0, 1, 2. First query tells at index 1 update the element to E. So index 1 we had A here, right? Instead of A we will now have E here. This will create an update operation. Next we go to the next query. It tells that at index 2 make it C. So make it C at index 2. So C. Third is in the range 1 to 2, what is the second largest character? That is in the range of 1 to 2, in this range. So this will represent the range, right? In the range of 1 to 2, what are the characters there? EC. What if you sort them? It will be CE. What is the second largest character? What is the second largest character in CE? It is C. C is the second largest character. E is the largest. C is the second largest. So the answer will be C. If you see, the answer is C. Does it make sense, Rishit? Does it make sense now? Anyone has any doubts? Clear? Okay. Okay. So let's actually think about it a bit. What are the operations telling us? The type 1 instead of, okay, let's forget about the operations that we are doing, like updating on the index and these things, updating the character and these things. The type 1 operation is essentially in an array of elements or in a character of elements. Let's say it is an array of characters. Replace this with x. A of I equals to x. That is basically type 1. Replace a of I, given I and x, replace a of I with x, where x is a character and a is an array of characters, which is called a string. Right? It is a array of characters, which is basically a string. Array of characters is a string. So it tells this a of I, replace a of I with x. The second element is, second query, what does it tell? It tells that given L2R, L, R and K, L, R and K, what is the kth largest element? What is the kth largest element? As simple as that. What is the kth largest element? Now here we have a one advantage. Like if it was array of integers, if it was normal integers and we would have been given like this, that would need something called a persistent segment tree or a merge sort tree. Like updates would not be supported by merge sort. So it would need a persistent segment tree, which is definitely not something that is asked in interviews ever. But here we have a very big advantage, right? We are given kth largest element. That's fine. How can we know the kth largest element? We know that the kth largest element will be one of A, B up to Z, right? It will be one of A, B, C, D up to Z. It will be a character. The kth largest will be one of A, B, C, D up to Z. Is it right? The kth largest element will be one of these characters. Is it correct? And we cannot have all the array values will also be within this only, A, B, C up to Z. Is it correct? What I'm saying is our answer will be one of A, B, C, D up to Z, and all these array elements are also A, B, C, D. That is, the string is made up of characters only, right? Up to Z. So all of them will be within Z. Let me know if this is clear. Yes. Our largest element range is restricted only to the 26. This is, what is the count of this? 26 only, right? Okay, let's forget about LR range, right? Let's forget about LR range. Let's just focus on the kth part. Let's say we are given the frequency of characters. We are given the frequency of characters. I'm coming to the solution. We are given the frequency of the characters, let's say, in an array A, or in an array called frequency of size 26, we are given the frequency of each of the characters. In this array of frequency, if we are given to find the kth largest element or kth largest character, can we find it? Can we find it? So in this array of frequency, we are given the frequency of each of the characters. Let's forget about ranges and all these things. Let's say we just have some frequency, like we just have a string. We just have some string. We have computed the frequency of characters here in array of 26. We just want the kth largest element, kth largest character that is there in the string. Can we use this frequency array to find the kth largest character? We can, right? Can we do this? We can. How can we do this? Pretty simple. We can just run a loop. Like, let's say, okay, let's just consider, like, instead of 26, let's just consider the first three characters, right? A, B, C. So let's say a string is made up of A, B, C. It's something like A, C, C, B, A, C, B, A, right? And K equals to fifth. What is the fifth largest character? So we'll just maintain the frequency. A frequency is 1, 2, 3, 4. B frequency is 1, 2. C frequency is 1, 2, 3. 1, 2, 3. So what is the fifth largest character? Fifth largest character will be B. 3 largest is C. C has only 3. So at B we'll start searching. At B we have 2. So the fifth largest. So after we are done with C. So C has 3. So we are searching for K equals to 2 here. What is the second largest between A, B? So we have 2 here. So B will be the answer. Yes, exactly. K minus equals to letters while going from Z to A. So we can do like this. We can run a reverse loop and just check which is the kth largest character. Simple. Now, okay, now we are done with the solution actually. We have found out the solution. Why? We just have to find out. We just have to find out in range L to R. Instead of finding this, just find this thing. In range L to R, find frequency of all the characters. In the range L to R, find the frequency. Yes, exactly. This was easier than the second one as well. Second one was easy because the constraints was less, but it would have been difficult if the constraint was like 10 to the power 5 or something. Yeah, in range L to R, find the frequency of all the characters. Right? Simple thing. And how can we do that? This is basically what? Kind of similar, like we have updates and in the frequency. Okay, now okay, let's rewrite the problem statement. So now we have to support two types of queries. First type is replace A of I with X. The second type of query is in range L to R. In range L to R, find frequency of all the characters. Right? So this is the problem that it has reduced to. Once we have the frequency, we can find the kth largest easily. Now, how can we do this? We can do this using a segment tree or a binary index tree or any range query data structure. Right? So let's think about a segment tree. What will each node of the segment tree contain? Each node of the segment tree will contain an array of size 26. Each node of the segment tree will contain an array of size 26 that represents the frequency. What does each node of a segment tree represent? Each node of a segment tree represents a range of the array, right? Let's say this is the entire array. Each node of the segment tree represents a range of the array. This array of size of 26 will contain what? It will contain the frequency of characters for the range this node represents. So this node, let's say this node represents this range, right? So it will contain the whatever characters are there, their frequencies, it will contain this in this array of size 26. Each node will contain the array of size 26, and what will they contain? They will contain the frequency of the characters that is represented by this range. Now, second thing is, how do we combine two nodes? Because in segment tree we combine two nodes to form the root node. That is, we have this one that contains the frequency of size 26. We have this one that contains the frequency array of size 26. They need to be combined to their root node. Again, what will this root node contain? This root node also represents a range, right? This root node also represents, like let's say this node represents this range and this node represents this range, right? So this root node will represent this entire range. So it would need the entire frequency. It would need the entire frequency, that is the summation of these two. The summation of the entries of these two, that will be there. So we'll just do what? To combine, we'll just run a loop for I equals to 0 to 26. Current of I equals to left of I plus right of I. Something like this. Left of I plus right of I. We'll just do like this. Okay. And that's it. Like once you're able to combine, and query is simple, the same thing. Okay, let's look into the code. Like we have understood the solution. Let's look into the code now. Okay, you got TLE, but I got AC. for some reason. Okay, anyways, so this is how we can do it. So what we have defined here, first of all, we have defined the segment tree. The segment tree itself will be an array, and each node will be what? Each node will be an array in itself, a vector of size 26. So this outer vector means the segment tree array. Each node itself is an array, so that's why vector int, right? We have taken the string s as well globally here or in the class as a data member. Now first thing is combine. Here we are combining two nodes left and right. Here we are combining two nodes left and right. So vector int answer 26 0. Now we are going through all the elements. I equals to 0, I less than 26, I plus plus. Answer of I is what? L of I plus R of I. What will answer of I contain? It will contain the total frequency. So what will be the total frequency of the characters? The number of characters, the frequency in left part plus the frequency in right part. Just think about it. A. What is the frequency of A? The frequency of A in the left part plus the frequency of A in the right part. That's what will contain. So this will be the combine method. Simple. After that, build, normal build in. So beginning equals to n means we have reached the root node. In the root node, for the corresponding index, like if it is A, it will be 0. If it is B, it will be 1. For that, we will have 1. For others, we will have 0. Right? So you can in fact maintain a bit mask for this as well. Or not bit mask, actually we want the count as well. So yeah, bit mask won't do. Right, anyways. S of beginning minus A equals to 1 and return. And for every other thing, we'll just recursively called build for the left part, for the right part, and then st of pos, that is the current element, will be the combination of the left child and the right child, whatever we have. Yes, beginning equals to end is the leaf node. This is the leaf node. So for that, only one of them will be like, only will maintain the frequency of the character there. Let's say there is a. So this will be st of pos of 0 because only equals to 1, and rest will be 0 because only one character is there. And others will combine, use the combine method. Any list to practice segment tree implementation? So you can just search for Codeforces segment tree, right? Segment tree questions, and you will get there are many like people who have written articles or blogs around like segment tree questions. So you'll get a lot of questions from there, right? Next we have update. Update is beginning equals to and again we have reached the leaf node. In that case, we are updating to character x. So we'll just set x minus a to 1 and rest of them will become 0 and return. And then we'll decide whether to go, like if the index is less than equal to mid, in that case the left part needs updating, the left subtree, or otherwise the right subtree needs updating. We'll just recurse to one of them and then we'll combine them to form the answer. Finally, query will be simple query, like we'll find the if it is within the range, we'll return st of pos, and this returns a vector of int. This is important. It returns a vector of int that will be the frequency of the characters in this range, right? And we'll combine otherwise the left query and the right query. Finally, we'll create the segment tree here as size 4 into n because we are using a recursive implementation. Now we'll go through all the queries. If it is equals to 1, and again, how to convert a string to an integer? We have this method in C++, s2i. Just use that. s2i. You will get lrk, right? So just run the query from lrk, and here you will get index and value, and just create the update. And now once you have this frequency, this answer is the frequency, right, of all the characters. Once you have that, you can run a loop from 25 to 0 while k to find the kth largest one, right? Like this. If k minus equals to answer of I, now if k greater than 0, I minus, and finally whatever I you end up at, that is the kth largest element. So push back k of I plus 97. Is there any classical problem on segment tree? There are a lot of problems actually. Classical is range sum, range minimum, range maximum, right? Like again, I'm not sure if there are questions like you can find in GeeksforGeeks definitely, but not sure in any other sites. But yeah, the classical will be the basics, range minimum. I'll write them down. Range sum, range minimum, range maximum. After you are done with these, maybe you can do like a second maximum in range. second maximum in range, and after that maybe if you want to like take it level up a level further, there are spoj questions. There are a couple of spoj question, GSSR1, GSSR2, like something like that, I think. GSS series, I think. Let's check once, right? The spoj ones. So yeah, they are very interesting questions. You can try to solve them. Spoj GSS. Yes, spoj GSS1. I think this one only. So spot GSS1 is a very interesting problem. It will really strengthen your segmentary understanding, right? Yeah. Can you answer these queries? So just try to solve this maybe after that. Anil, already someone has told you have missed the limit, right? So it I plus j, you have to restrict it to, j will not be I plus k, but you have to restrict it to n. If let's say I is n minus 1, so I plus k will exceed n in that case, right? So you have to restrict it. Just read the comments, it will help you. 4 into n, because when we are writing a recursive segmentary, we have to take the segmentary size as the nearest power of 2. So the nearest power of 2 lies within 4 into n. So there are two ways to implement the segmentary: recursive, which is the most common way, and there is the iterative implementation as well. Iterative implementation, if you want to learn, there is a Codeforces blog around it. Just search for Codeforces iterative segmentary, you will get it. It's pretty, like, the code becomes much smaller. Like here we have like around 70-80 lines of code. It will reduce to 20-30 lines of code. And for iterative you need an array of size 2 into n. For recursive you need 4 into n. For a binary index tree, I think you need a size of 2 into n or order of n, right? So yeah, those things are there. Search of I. Cool. Find time, search k1 dp in b, search 0, find time. Search 0 plus, by search 0, search I. Okay, you've done search I plus find j equals to 1, j less than, okay, not j less than I plus k minus 1, j less than equal to, so it will be j less than equal to I plus k. It will be j less than equal to I plus k, because you are recursing next to what? Search k I plus j. Yes, you are recursing to I plus j, so the loop is wrong. It will be j equals to 1, j less than equal to I plus k, j plus plus. And not I plus k, right? J less than equal to k, j less than equal to k. The loop will be for I equals to 1, j equals to 1, j less than equal to k, j plus plus. Just correct it, it will work. Okay, anyways, okay, I hope there are no questions. So yeah, thank you guys for joining, and I'll be seeing you next week.